Hey guys, welcome to today's tutorial. We're going to be looking at some exam questions to finish up the section on the normal distribution. Okay, so the first question, we've got a multiple choice. Results for an aptitude test are given as z-scores. In the test, Di gained a score of z-score of 3. The test has a mean of 55 and a standard deviation of 6. What was her score? Well, she got a score of 55. And we're going to add to that the z-score of positive 3, so that means we're going to add to it, and then we're going to times that by 6, so 55 plus 18, and that gives us a score of 73, so my answer there will be D. Okay, the next question. Results for reading tests are given as z-scores. In this test score, Kim gained a z-score equal to -2. Interpret this z-score in terms of the mean and standard deviation. Okay, this means that Kim's score was 2 standard deviations below the mean. Beautiful. Okay, part 2. If the test has a mean of 75 and a standard deviation of 5, calculate her actual score. Okay, well, she's got 2 lots of standard deviations below the mean, so that's 10 marks below the mean. There, 75 take away 10 is equal to 65. Therefore, she had a score of 65. Okay, next question. The weights of boxes of Brekkie Bix are normally distributed. This means that we have a nice bell curve of a mean, and it has 754 grams as the mean with a standard deviation of 2 grams. So I'm going to go up to 1 standard deviation with 756, 2 standard deviations 758. Look, it's going up by 2, so I'm just going to do those ones there. I also probably need to have some negative ones, so 752, and likewise, because it's going down by 2s, it's probably easier just to do all of them. Okay, so -3 will be 748. Okay, so let's look at the questions. Question 1 says, what is the z-score of a Brekkie box that has a weight of 754? Okay, well that has a z-score of 0 because it's exactly the mean. Part 2 says, what is the weight of a box that has a z-score of -1? Well, that'd be 752 grams. And then the third one says, Brekkie Bix boxes are labeled as having a weight of 750 grams. What percentage of boxes will have a weight less than 750? Well, if I'm looking at my percentages, I'm looking at the last two. That's 0.15%. That's 2.35%. Therefore, I've got a total of 2.5% that are below 750. Beautiful. Again, not too challenging for those ones there. Number 4, the results of 2 class tests are normally distributed. The means and standard deviations of the test are displayed in the table. Stuart scored 63 in test 1. So he got 63 in this one, and he scored 62 in test 2. He thinks he has performed better in test 1. Do you agree? Using calculations to support your answer. Well, let's get Z's score of the first one. So that's going to be a score of 63, take away 60 all over a standard deviation of 6.2. And we're just going to plonk that into our calculator. So 63 take away 60 all over 6.2. That gives me a standard deviation, okay, of 0.48387 ... So not particularly nice number there. The z-score of the second test is going to be 62 take away 58 divided by 6. So again, I'm going to put that into my calculator, and we get an answer of 2/3, which is 0.6 recurring. So he thinks he's performed better in test 1. Do you agree? No, I do not agree. Justify our calculations. We have got the 0.6 and saying his Z score is higher for test 2, therefore further above the mean. Okay, now part 2, I'm going to have to do up here now, unfortunately, we're out of room. If 150 students sat for test 2, how many students would you expect to have a score that is less than 64? Okay, so this is going to be referring to a percentage of 150. So I need to figure out what percent is going to be less than 64. So my mean for test 2 was, 58, had a standard deviation of 6. So one standard deviation will be 64, and that's the score that we've got. Okay, and we want a score less than 64. So we've got 50% here, we've got 34% here, therefore we've got a total of 84% of scores are less than 64. So what my estimate would be 0.84 times 150 students, and then put that into our calculator to get 126 students. I would expect to get a score of less than 100, so less than 64. Pretty tough question, that one, hey? All right, let's go to the last question. 2 brands of light bulbs are being compared. For each brand, the life of the light bulbs is normally distributed. One of the brand B light bulbs has a life of 400 hours. What is the Z score of the life of this light bulb? So again, you might choose to do a nice big bell curve. In this case, I'm just going to do my score, which is 400. I'm going to take away my 500, which is the mean of brand B. I'm going to divide it by my standard deviation. So 4 take away 5 is negative 100 over 50. I put that in my calculator, we get a score of negative 2. So it's 2 standard deviations below the mean. A light bulb is considered defective if it lasts less than 400 hours. The following claim is made. Brand A light bulbs are more likely to be defective than brand B light bulbs. Is this claim correct? Well, I have to have a look at brand A as well. So I'm going to draw a bell curve for brand A. Okay, that's going to help me to distinguish how far below the mean brand A is going to be. So the mean is 450. Now it says 400 hours, so I'm going to go to the left of that. So negative 1 will be 425. Negative 2 will be the 400 that we're looking for. So what we're looking for is a Z score of negative 2 for A, but it's also negative 2 for B. Therefore, is this claim correct? I would therefore say no, they are the same or just as likely as each other. And then brackets, I'm going to put both equal Z score of -2. So I've shown that they both contain a Z score of -2, therefore they're both just as likely to be defective. Look, I hope those sort of helped you and you kind of understood what was going on with those questions. There's a good variety there. There's always a couple of questions in the HSC and particularly the trial, so make sure that you're aware. Remember, if you see that word normally distributed, if you're not sure where to go, certainly drawing a bell curve is a really good way to start, or looking at your formula for the Z scores. Any questions, let me know. Otherwise, that is your normal distribution chapter done and dusted. Have a great day.